What's up, mathematicians? In this video, I will be giving some solutions and hints to problems about the tangent ratio. Let's go ahead and get started here. And so let's look here at problem number 1. Problem number 1 says in the video, now I'm talking about the video for lesson 1 actually, the video on measurement, introduction to measurement. In the video, I state that angles are magnitudes. Right? And I talk a little bit about the difference between a magnitude and a quantity, and explain how this fits in with the definition of magnitude that I provided. A magnitude is anything made up of parts in any way like itself. So in order to do this, you might think about, okay, if I have an angle, here's some angle, and we can even label it, right? We have angle A, B, C, okay, so angle A, B, C. Now what I'm claiming is that an angle is a magnitude, which means it can be made up of parts like itself. Well, if you divide up an angle, you get smaller angles, right? So all these parts are also themselves angles. And in that sense, an angle can be thought of as a magnitude because it's made up of smaller angles. Oftentimes we would think of the small, not the smallest, but as like 1 degree as being sort of the element, the building block, if you will, that an angle is made of when we're measuring in degrees. However, even a degree can be divided into smaller pieces, but even those smaller pieces would themselves be angles. So yeah, so you can write something about that. Diagrams are also helpful. And for number 2, let's look at the number 2 here. And it says for part A, let's see, what is the relationship between the angle of elevation for the cat and the angle of depression for the bird? So maybe this angle here is an angle of depression for the bird. If the bird has to look down on this cat with a staring at it in the cage there. But also those two angles are called alternate interior angles, often abbreviated AIA. And let's see. Yeah, so that's the relationship. And another part of the relationship with those two angles is that since these two lines are parallel to each other, the two angles are also equal. So you could say the alternate interior angles and that they're equal. And as I already stated, part B says, what can you say about the two horizontal lines? How are they related? They are parallel. So that's really the thing that you can say about those. Okay, so let's go on to number 3. Let me just move this down a little bit. All right, number 3, and I'm just going to go ahead and go to the end of this one, give myself some space. Actually, I'm going to move, sorry for the delay, I'm just going to move this whole thing down a bit here because otherwise I might run out of space. Okay, so a boat ramp has a rise of 7.5 feet over a run of 50 feet. And this problem is, main part of the thing I want you to get from this problem is the understanding that when we talk about rise over run, rise over run, that should remind you of a concept from algebra class, which is the concept of slope, right? So we think of rise over run as being slope. Well, the slope is also the tangent of some angle, right? So it's the tangent of some angle is the slope of that angle. And so when I ask what is the slope of the ramp, well, you're given the rise over the run. And so for part A, we'll say, well, the slope is 7.5, which is the rise, divided by 50, which is the run. And you can just go ahead and type that in a calculator. and we get 0.15. So that's the slope of the ramp. Now it says, what is the angle of inclination of the ramp? So what is this angle right here? I can put in a theta there if that helps us. Yeah. So what is that angle? What is that angle theta equal to? Okay, so you know that the slope is the tangent, but what is the angle? And so one thing that might be helpful, I talk about tangent as a ratio in the videos, but we could also think about tangent as a function. And one thing that might be helpful is the following. So let's see. If we think of tangent as a function, what do we put into that function and what comes out of that function? Well, the kind of thing that we put into tangent is an angle. So the angle goes into the tangent function, and what comes out of the tangent function is a ratio, which in this case is a slope. Or any case, really. What I'm saying is that if this angle has one of its rays horizontal at least, you can just consider that ratio to be the slope of the angle, if it's an angle of inclination. And what if we have a ratio or a slope, which right now we're using those interchangeably, and we want to get the angle? Okay, well, it's should make sense that it's the inverse of the tangent operation, because the tangent operation or function, the input's the angle, the output's the ratio. And so if I have an input of a ratio and I want to output the angle, then I want to use the inverse tangent, which is also known as the arc tangent. Oops. So on some calculators, you'll see, in fact, most calculators usually tangent to the -1. On the calculator that I'm using over here, you'll see it's actually a tangent, which means arctangent. They're exactly the same thing. And maybe that's confusing, but I don't know. I don't know what to tell you. Wasn't my decision. I actually prefer the arctangent rather than this -1 here, which makes it seem like maybe it's 1 over tangent, which it definitely is not. It is the inverse of tangent, not 1 over tangent. Okay, so let's back up. Part B says, what is the angle of inclination? So we know the slope, which is this right here, and we want to know the angle. So what that means is we want to put this slope into the inverse tangent. So since I have the a tan on the calculator on the screen here, I'm going to say a tan of 0.15. And what does that equal? Well, let's find out. So shift a tan 0.15 and 8.53, etc. So I'm just going to round to the nearest tenth. 8.5 degrees. Now, if you got something different, make sure your calculator is in degree mode, because if it's not in degree mode, you won't get this answer. You'll get an answer in radians. But yeah, if your calculator is in degree mode, you should get this. However, another option here, rather than plug in a calculator, is to look at a table. And let's see what would happen if we looked at the table. So again, keep in mind that the slope or the ratio is 0.15, and I actually have a table up here. Let's go up here. And okay, so over here I have my angles, and over here I have my tangents, which are my slopes or my ratios. And as I go down this list, I'm looking for 0.15, and I see, oh, right here, basically, right? Here I have 0.14, and here I have 0.16 if I run to the nearest hundredth. And so that means that the angle should be between 8 and 9, and in fact, as we see in the calculator, it is 8.53, etc. So by looking at the table, we can also get a pretty good idea to within probably the nearest degree or so of what that angle will be. Okay, so that's part B. Part C, I don't know. This might seem a little repetitive, but I'm just asking you to, I want you to understand the connection between the slope and the tangent. And if you take the tangent of the angle of inclination, so the tangent of 8.5 degrees, what you're going to see, let's see, tangent 8.5, and actually we have more. In fact, I could have, hang on, let me actually use this functionality here. Answer, so it recalls the answer to the previous problem, and I hit enter, and I see, oh, well, sure enough, I get 0.15 back out. So the tangent gave me the slope, right? I saw that 0.15 was the slope, and when I took the tangent of the angle, of course, I got the slope. So yeah, a little repetitive, but I just want to drive that point home. Okay, so part D, the slope of the ramp and the tangent of the angle, they're just the same, basically. How are they related? They're related by being essentially the same thing. And finally, part E, if the angle were 12 degrees, what would the rise be for a run of 50 feet? So I would definitely draw a diagram here. So let's go ahead and draw a diagram. And what I'm saying is that this angle is now 12 degrees. The run is still 50 feet, right? As it says right there. Angle is 12 degrees. What would the slope be? Oops. Yeah, sorry, I'm getting ahead of myself. First I'm saying, what would the rise be? Okay, so that means I want to find this value right here, x. Okay, so, and actually we're going to end up finding the slope before we even find the rise. So let's see. I know that the tangent is the slope, which is rise over run. So that means the tangent of 12 degrees is equal to the rise, which is x, divided by the run, which is 50. Okay, so now I have a couple options. I can plug this in the calculator. I can also, let's actually look at the table. Let's do that. So let's find out what the tangent of 12 degrees is from the table. And here's 12 degrees, and I see the tangent, if I round to the nearest hundredth, is 0.21. So let's go up here and replace tangent of 12 degrees with 0.21. We can double check on the calculator. Tangent 12 degrees, sure enough, 0.21 round to the nearest hundredth. So that is equal to x over 50. So if we want to know what x is, we can just multiply both sides of this equation by 50. And so let's go ahead and multiply this times 50. And I get 10.6. Okay, so x is equal to 10.6. So what is the rise? The rise is 10.6. I'll go ahead and put that in there, 10.6. And what is the slope? Well, it's the tangent, which is 0.21, rounded to the nearest hundredth. Okay, so that's number 3. Let's go on to number 4. All right, so for number 4, I'm actually going to do this again, give myself plenty of space to work with. And okay, so for number 4, I have a 45-meter lighthouse, and I have an angle of depression of 26 degrees, and I have, a swimmer, right, in the water. The lighthouse is on the edge of the shore. It's not up on a cliff. Sometimes these problems, lighthouse is up on a cliff, but that's not the case here. So let's go ahead and draw in the lighthouse. Okay. Okay, and then we have our swimmer is over there. And there is my beautiful, beautiful lighthouse. And so what we're saying is that, okay, the height of the lighthouse, as specified, 45 meters. And then let's draw in, I'll just draw it as let's draw it in as a straight line here. Okay, so now remember that an angle of depression is an angle below horizontal. That means this angle is 26 degrees, not this angle right here. That's a different angle. Okay, but as we can recall from problem number 1, or problem number 2 rather, if the angle of depression is 26 degrees, then the angle of elevation here is also going to be 26 degrees. Those are equal. Okay. So now we see we have a triangle, and the question is, well, actually, A says draw a diagram. We just did that, so that's great. We've done part A. Good. Okay. Now it says draw a similar triangle in your notes with a base of 100 millimeters. And so, yeah, I mean, I'm not doing this with my document camera right now, so I'm not going to actually measure it out, but I'm just going to say what I'm asking you to do is draw out this triangle, so it's 100 millimeters, and then use your protractor and draw a 26-degree angle. Okay, and then use your ruler to find that length right there. Okay, and if you draw it well, like if you do a pretty good job of getting this angle correct in 100 millimeters, and then you use your ruler to find this unknown side length, you should get very close to 50 millimeters, just under 50 millimeters. Okay, so measure to the nearest millimeter. Should be just under 50 millimeters if you do a good job of the drawing. Okay, so now it says find a table. Part C says use a table to find the tangent of 26 degrees. Now, since your measurement here, you measured the rise. If you got 49 millimeters, which would be the closest, if you did a good job of the drawings, 49 is the rise and 100 is the run, you would expect the tangent to be about 0.49. Now let's look at the table. Scroll up a ways now and look at 26 degrees, and we see the tangent is right there, 0.4877, which rounded to the nearest hundredths place is 0.49. So why did I have you do this? Well, I wanted you to go through the practice of drawing it out and measuring it in your notes and seeing that you can use that method to find the tangent. Even though when you're actually solving problems, you're probably not going to do that rather time-consuming activity. But that's how these things can be calculated, just with measurement. And we can also, of course, double check on the calculator, see what the calculator says. And yes, 0.4877, so 0.49 rounded to the nearest hundredths place. So we have the tangent of 0.26, and now we can find out how far the swimmer is from the shore, or from the base of the lighthouse. So that is trying to find this distance right here. Okay, so I'll call that x. And so we can say, okay, the tangent of the angle, 26 degrees, is equal to the slope, the rise over the run. Well, the rise is 45, and the run is x. Well, I know that the tangent is 0.49. I verified that with a measurement if you drew the triangle properly. Also looked it up in the table and used the calculator 3 different ways. A bit of overkill, I know, but we're learning these concepts, trying to really understand these concepts at a deeper level. And so we know that the tangent is 0.49, and so then we can say, okay, 45 over x. And solving this for x, you're going to end up multiplying both sides by x, divide by 0.49, and you'll get x is equal to, let's see, 45 divided by 0.49 is 91.8 if you round to the nearest tenths place. So 91.8 meters. That is the answer to part D. Okay, so now let's go on to number 5. Let's see. Do I want to do this one? Yeah. Let's let you do that one. And let's go on to number 7, actually. I'm going to go on to number 7. Oops. Keep these numberings consistent. Okay. So number 7, imagine you climb a tree to the point where your eye height is 10 meters above the ground. And you look down and see a mouse on the ground. The angle of depression from your eye level is 33 degrees. Okay, so we're 10 meters above the ground. So here we go. So you definitely draw a diagram here. I'm going to draw, this is the ground. Ground might not be totally flat, but we'll draw it pretty flat. And then we have this tree. And I don't know, I'm not going to even bother trying to be artistic here. But point is, you're like hanging out in this tree. I'll just, here, I'll just be right up here, right there. All right. And from this tree, your eye height is 10 meters above the ground. Okay. You look down and you see a mouse on the ground. So from eye height, here's a little mouse right there on the ground. And the angle of depression from your eye level to the mouse is 33 degrees. Okay, so angle of depression is angle below horizontal. So I'm talking about this angle right here, 33 degrees. Well, since these are alternate interior angles, this will also be 33 degrees, just like we discussed in question number 2. All right, now the first question is, what is the slope of this line? Part A. Find the slope of that line. Well, you know the angle of inclination, or the angle of elevation, is 33 degrees, and you also know that the slope is given by the tangent of the angle. So all we need to do is take the tangent of 33 degrees. That gives us the slope. You could also look it up in a table. Or you could draw a to-scale diagram and measure it. In any case, for part A, we know that the slope is the tangent of 33 degrees, which is equal to, I know it's actually approximately equal to, but rounding to the nearest hundredths place, 0.65. Okay, so that is the slope. And part B says, how far is the mouse from the base of the tree? Well, I know that the rise is 10 meters, but how far is the mouse from the base of the tree? We'll assume that you're directly above the base of the tree. These are the kinds of assumptions that you have to make in some of these math problems. And so that's going to go ahead. That'll be my x. the distance from the mouse to the base of the tree. So let's see. The slope is 0.65, and we know that slope is rise over run. So 10 over x. And solving this for x, let's see, we multiply both sides by x and divide both sides by 0.65, and we'll get x is equal to 10 divided by 0.65. And let's go ahead and do that. So 10 divided by 0.65, we get 15.4 rounded to the nearest tenths place. So 15.4 meters. So that is part B. That is the distance from the mouse to the base of the tree using the tangent ratio. Number 8 is saying, consider the problem above. Can you determine how far the mouse is from your eye? So what we're asking there, let me actually pull out a different color here. We're asking for this distance. You know, what is the distance from the mouse to your eye? And since this is a right triangle, you know, we can see we have a right triangle here, assuming you're directly above the base of the tree, of course. There are a few different tools we can use to find this, but no tools we've actually learned about. So it says, can you solve this problem with the tools we have? Proportion, similar triangles, the tangent ratio. Actually, you could draw a to scale triangle and do the calculation. Use similar triangles with a little bit of work. You could also use something called the Pythagorean theorem. If you know the Pythagorean theorem, that's a topic for a future lesson. But more importantly, what I want to point out is that we are using the tangent ratio to relate the rise and the run. But the other two ratios that we haven't learned about yet, which are the sine and the cosine, those two ratios will actually involve that longer side, which is called the hypotenuse. So stay tuned. We have tools for doing this that we'll learn about: the sine, the cosine, and the Pythagorean theorem. We'll learn about those in future lessons. So stay tuned for that. Okay, so those are some application problems. And let's see, how is my time doing? I'm coming close to half an hour here. I don't want these to get too long, but let's look at, let's see, problem number 9 is the last problem. So let's see, what do I want to say about problem number 9? It says, in the lesson, I claimed that by assuming all right triangles have the same angle sum, it would follow that the third angles in two right triangles that have a 35-degree angle must be equal. Prove that this is true. And what should the measure of the third angle be? So let's go ahead and draw two triangles here. Okay. And these are both right triangles, and we're going to say that one of the angles is 35 degrees. I'll go ahead and draw one bigger than the other. Okay. And now what we're claiming here is that since these two triangles have the same angle sum, those two angles here and here must be equal or congruent, if you'd rather use that term. Okay, and how would we prove that? Well, let's go ahead and say that A is equal to the angle sum of all right triangles. Okay, and let's call this angle here x, and let's call this angle here y. We want to prove that x is equal to y. Okay, well, we know that x plus 35 degrees plus 90 degrees, which is the right triangle, is equal to A, the angle sum of all right triangles, because I'm saying all right triangles have the same angle sum. Okay, but I also know that y plus 35 degrees plus 90 degrees is equal to A. Okay, So if this is equal to A and this is equal to A, doesn't it follow that that x plus 35 degrees plus 90 degrees is equal to y plus 35 degrees plus 90 degrees? Okay, well, 35s cancel out, 90s cancel out, and I'm left with x equals y. So there we go. That is my, argument, proof, basically. Not that I've written out all the steps, but yeah, that's my proof for why those two remaining angles have to be equal. What do you think the measure of the third angles will be? Well, I'll let you figure that out. Most people by this point in their high school math career have heard that the angle sum of a triangle has to be 180 degrees. And if you believe that's true, you know that, you have a 35, you have a 90, and what would y or x have to be for that total to be 180 degrees? I'll let you figure that out yourself, because I think I've gone on long enough for this particular video. So let's stop it there. Thank you for watching. I do hope you found this helpful, explaining some of these example problems. And yeah, I'll do another video on other example problems, and join us then. All right, thanks. Bye-bye.